You're on mute. You have to unmute yourself if you want be heard again. What was the question?
Yes, yeah, I was mute. No, if you just could try to put your microphone a bit closer. We can hear you, but I think if you put it closer to your mouth, you might be clearer.
Is it better? Is it better now?
A little bit, I think so. Yeah.
Okay, we try that. Yeah. So this is DISC, and this is the collaboration that Idar, Helge, Charles, and I are part of. And we have done a lot of work with IMF and PCA to expose this framework to the most amount of users in our industry. So I'll come back to that with more information about the libraries. So the issue or challenge that we see, and this isn't specific to the oil industry, but across industries, is that we are replicating the same work when we talk about equipment classes and equipment attributes, and when we exchange this data. So we waste a lot of time, money, and resources exchanging data when we could be using a standardized template for equipment classes and attributes and different perspectives of these types of equipment from different aspects. And that's something that IMF can offer us. And if we look at the situation now, when we're exchanging data, you know, every supplier, manufacturer, EPC, operator, we have different attributes, and we're all like describing the same things, but we're using different naming conventions for the same information. So what we propose with IMF is if we could normalize these attributes and we could all have references to the same information, then it would make it much easier to exchange information and have semantic interoperability if we have some kind of reasoning on top of this. In addition to this, we all try to create system breakdown structures. So for example, here in the middle, you have like a piece of equipment and you have all these different relations. So for example, the generic application of this equipment, the generic product, the functional relations, what kind of software is installed on it, the system breakdown structure, what service is affected if this equipment fails, who should be contacted upon failure, transmission, and this is across industries, network, redundancy, locations, power. And this is something that we'll see from the different aspects in IMF that we could represent with different normalized attributes. And then we can build these spider web of structures and relations to represent dependencies between equipment. So what we see today is that, for example, operators, they set requirements, functional, system operational requirements. They send these specifications to, for example, contractors, EPCs, who have to check that they can offer solutions, build solutions that are according to these requirements. And then they might also check with their manufacturers if they have parts or products that can be used as part of these solutions. And so we are verifying and validating the same attributes over and over again, calling them different things, and using lots of time and resources to do this work. Sometimes it's done programmatically. Maybe one of these companies might have scripts to do some kind of mapping between attributes they know are the same, but it's not sustainable over time because we rename attributes, we migrate to different systems, we get new attributes, so then we have to continuously do these mappings and keep them maintained. And then when it's sent back to the operator, we have to have subject matter experts verify that what they've been delivered or what an EPC is offering fulfills those requirements. So it's very redundant, it's very mundane work. And what we are looking at with IMF is if we could exchange IMF types, these standard templates for equipment classes and related attributes, then we can save a lot of time and headache for these subject matter experts who are, just doing repetitive tasks with verification and validation. And instead, we could be using them for more complex reasoning, right? To verify and validate if there's something special that has to be checked that a machine couldn't check for us. So just to highlight the problem here, the problem is that we have different data sources, we have different languages, we call things different names. And with IMF, we have a common foundational language, and it makes it much easier to exchange information and also to take quicker and more informed decisions about that information throughout the entire life cycle of equipment and projects. So the definition of the information modeling framework, we say it's a structured approach for organizing and managing information across complex systems and projects. IMF started as a part of the READY project that DMV led in, I believe it was the end of 2018 and ended in 2021. And it was to make work processes more efficient and data information exchange more efficient through standardization. And IMF is based on well-known standards like ISO 81346, where we have reference data designation systems for structuring equipment based on classes and normalized ways of or normalized naming conventions. And in addition to that, we also have an alignment with the industrial data ontology, which is in, I believe, still in a draft in ISO 23726, part 3. And the industrial data ontology is an upper vocabulary that describes industrial data and equipment and related classes and relationships. So this isn't something that we've just pulled out of thin air, right? It's been a long time in development, and it's based on well-known standards. And what's important to talk about here is that a lot of our companies, we're talking about digital transformation, about building digital twins, using machine learning and AI to make better decisions. But if we don't have a structured foundation for our data, we won't be able to make quick and well-informed decisions. And that's something that's really important that we can have with IMF, right? This, these normalized attributes. And it doesn't mean that we can't use other attributes, but there are extensions to IMF that we can have, and then we can have these structured classes with references to other reference data libraries. So that's really important to point out when we're building these digital ecosystems in our companies. So in IMF, we have core aspects, and these are these different perspectives that I was talking about earlier. So for example, if we look at a pump here, the pump is what we call an IMF type or equipment class. And we have these core aspects: functional, product, plant, and location. And we also have installed aspect. But we can have many other aspects with their own related attributes. So for example, we could have a cybersecurity aspect with network information and security protocols. We could also have a maintenance aspect with maintenance plans and how often something, should be replaced. And this is Jan Slatterbakk was supposed to present with me, but this is just an extension of these different aspects. They come from ISO 81346. So we're in alignment here with these functional, product, location, plant aspects. And if we think more basically about how we can build these aspects to represent equipment, everybody knows about Lego blocks or Duplo blocks. if we have these different colored blocks that represent different aspects, the functional aspect could represent, of course, the function of equipment in an early life cycle phase of systems. The plant aspect can represent the requirements for the actual plant or facility where the equipment is going to be installed. Location represents the spatial aspects of the equipment, perhaps coordinates or maybe ATEX attributes. The product aspects represent what is found on the market and what we can actually buy. And then the installed aspect is, when you've actually installed it on site, and then you can have the serial number and other attributes related to that aspect. And then we can begin to put these blocks together to have a more holistic perspective of the equipment. So in this example, we have a temperature transmitter, which has relations to a sensing element and instrument housing. And in IMF, we have the concept of terminals. So you have these different types of connections, inputs and outputs to different IMF types. And then we can see how these fit together, right? That you can have a cable connection between different types of equipment, right? Going in and out, and that's something that could also be documented. And then over time, we can start to build these really large information models, right, of dependencies and how they affect each other and how they communicate. And this isn't just theoretical, this is something that's already found and exposed via PCA. They have an API that's available with the information modeling framework library. We have over 60 equipment types that have been modeled and are made available with different aspects. Not all of them are completely modeled yet, but it's still a work in progress. But we made good headway right before Christmas last year. We had Draga, which is a IT consultant company. They used they modeled and normalized attributes based on NORSOK product data sheets to help us create these IMF types that we now have available in the PCA library. So that's something that I can send the link out for at the end of this meeting, and we can also have a look in the library. Another thing is that the value of IMF is that over time, throughout the entire life cycle of facilities and equipment, we potentially lose information as we, through the engineering design processes, through commissioning, through maintenance and decommissioning. And this is because historically we've just exchanged PDFs, right? We've exchanged documents. And we have a bigger focus now on moving from documents to data. And this is something that we're able to actually realize with the use of IMF and semantic data modeling and use of ontologies, that we don't need the entire model to deliver information, but we can take bits and pieces and build it up gradually with these different aspects, the functional, product, location, plant aspects, and they may come at different stages. And what's really great is that when we want to come back and modify something, that, for example, if we go into a new contract with an EPC, that they have historical information that they can go back to without having to go through multiple PDFs to see what was delivered. And I've also heard about EPCs having to go out to the actual platform to verify and validate that what's in the documentation actually matches what's found in real life. And that's something that's really valuable here, that we have better control over the data and information that we're receiving, and we can run reasoning over that to make sure that what's expected to be delivered actually is delivered, and according to requirements, and that, throughout the whole entire life cycle phase, we can, trust what's this like single source of truth for projects and for equipment. So this is something that it's not just valuable for operators, but it's valuable for manufacturers and contractors as well. And this all fits into the V model, right? When we're starting off with a project and we're setting requirements, and we can do this digital compare reasoning from the beginning all the way to a handover. And it's really great that when we use a common language to speak about equipment classes and attributes and systems and projects, that every discipline has their own language, and we can continue to use those languages internally within our disciplines. But across disciplines, that's where we can use these references, these templates with IMF to communicate about the same information from different perspectives. So it could make it way more efficient, and we can actually prevent miscommunication, misunderstandings, because we all have this common vocabulary to talk about the systems that we have and that we work on. In addition to this, an advantage is that you can run consequence analysis. So at the top of this drawing, you see that we have representation of the functional aspect. And on the bottom, we have the product aspect in blue. And, we can see if a function fails, how many other functions are affected by such a failure? How many other pieces of equipment could potentially fail, right? So this also plays into barrier analysis and catching failures before they become larger failures. And so, that's another thing that we could take into account here when we're building up aspects, how they hang together, and also save money, time, and resources, and actually affects scheduling, right? When we think about maintenance and what is a critical failure and what needs to be prioritized above other types of failures or warnings. We also have an IMF references to other reference data libraries. So with PCA, these ovals in green represent what we already have some reference to in the library. So for example, here we have a temperature transmitter, but you could also see how it's described according to SHIFOS, according to the Common Data Dictionary, according to PCA's reference data library, and potentially to IDO. Currently, we in DISC are working on expanding the mapping to EQ Hub for the product aspect, but we can have many other references to other data libraries, repositories, and standards over time. And then everybody can, maybe use less time on creating their own mapping to these reference data libraries, and instead we can all have a reference to something that has, the single source of truth mapping for us. Going back to reasoning, we can use these IMF types to compare attributes and values that we have within these different aspects to see, for example, that a product or a piece of equipment that we want to replace actually is that's offered, for example, on the market, could actually fit into our infrastructure according to requirements, right? Um, and that's something that we can do with machines to do the work for us to compare these different values. So as long as we set the requirements and they're stored in our systems, and then we have these IMF type templates, then it's pretty easy to just create rules based on this to ensure that we are sticking to requirements. Last year, I ran a project that showed a proof of concept for this, where we use JIP33 product data sheets. And then we ran some use cases where we showed that there were some products that EQ Hub found on EQ Hub could fulfill operator requirements, and we showed that we could catch missing values that a supplier or an EPC had delivered. We could catch typos, we could catch units of measurement that weren't filled out, minimum values that were greater than max values, and different types of ranges that weren't didn't fit in. And that way we can save a lot of time, because if a lot of this work is being done manually now or is being manually configured, then we can have more automatic ways of running reasoning, you know, to do replacements and actually to optimize performance as a whole. So what kind of value does IMF provide for us? It's less human error throughout the entire life cycle, right? We can set requirements about what kind of data needs to be delivered according to, for example, data maturity levels. We can improve data quality because we know what should be expected, right? And that can be programmed, right, into what's obligatory to deliver at a certain point in time and what's preferred and what's optional. It supports modifications because we can go back and we can see the history of what has been delivered, and we have better control over the whole life cycle as information is delivered. We can validate with reasoning, as I just explained. We can also inherit requirements if we have functions at the top of the IMF model and subfunctions. Those subfunctions can inherit those same requirements that are set in the specifications. We can support impact analysis, and we can catch failures before they become larger failures, and we can see the whole consequences of such failures. And it supports predictive maintenance, because then we can also, besides catching the failures, we can also prioritize which ones are most critical. It supports our initiatives for moving from documents to data and creating a common vocabulary to talk about equipment classes and attributes. We can also connect this to real-time data. And this all ties back to impact analysis and just having better control of our assets. We can also link technical drawings to these IMF types. If we think about block flow diagrams, process flow diagrams, the traditional documents, you can't drill down into these systems and see what kind of components they comprise of. But if we have these IMF types that we can use to build up our information models on our data platforms, then we can have these links between drawings and have a better holistic overview of how they hang together and move quickly between drawings to make more informed and quicker decisions. And then, of course, better operational efficiency. There's less waste, right? We're saving time when we could be reasoning over IMF types and the information that's delivered to us and in a more automatic way. And then the people who have been doing these kind of verification processes today, they could focus their efforts on more pressing matters. IMF is something that at least we in Aker BP are looking into using in our Yggdrasil project. we don't have requirements that EPCs have to deliver in IMF format, but it's something that we think is the closest thing to help us to go from documents to data, in addition to other standards and methods for example, with DEXB and other DISC initiatives. But we see it as this foundation that could help us build the digital twin that we want and connect it to other reference data libraries like SheFOS and CDD and yeah, other standards. Yeah, Charles, Idar, do you have any additional information from your perspective from a operator and EPC perspective about how what kind of value you see for IMF in your companies?
I don't see Idar unmuting, but I can start, Idar. So from our perspective, we share kind of the problem formulation, Veronica, and see that we understand or that this interoperability is not easy as of today. We do also share the conceptual kind of vision that we need these vocabularies, these RDLs, and so to do the exchange. So there's a lot of potentials in implementing this. One of the main challenges, as I see it, is that when you have an interoperability kind of concept, you need two to make a tango. So you need both ends to talk the same language, and then you need to come up on a certain level also on the scope that we have. So from a conceptual point of view, it's kind of a lot of making sense here. But we have kind of struggled to make this work in practice beyond the POCs. But I think when we get this working between kind of major parties, I think that will be a major uptake.
Idar, do you have any reflections?
The reflection is also this seems like a huge job, but I think also the approach for us is to take it bit by bit, and it's and we need to, and it's a huge value in this for us as well. We see that. It will, as I say, break apart all the documents and Excel sheets and things that we have to go manually through today, and we want to really, as you say, crawl through all this data that are there, that these drawings and represents. We will be able to do that, but this is a long way to cover to be able to cover everything. We will never end this journey that we start on here now. That's for sure. We will start on some bits, and we want to do next bit, and it will go on. But it doesn't. I don't think we will lose control of it if we take it gradually and systematically. And that is what we're trying to do.
And I think that's why we need a lot of input from, subject matter experts, right? So the work we're doing and making sure that we're prioritizing the right attributes that are exposed from the library. And I just put the link in the chat to the PCA library so you guys can check it out. This is what it looks like. And then you can start to search for these different IMF blocks. So for example, and then you can start to see that there's different aspects that have been exposed, plant, product, installed, and see what's actually what the attributes are found for these different types of equipment. Looks like that one doesn't work, but looks like there might be an issue with the library right now. Talk to PCA about that. Additionally, you can, if you see some attributes are missing, you can suggest attributes. And I think I still have it up here.
Yeah. But I think also one of the intention by this meeting is that the different SMEs now, or also people, discipline people here, understand what we are starting to talk about our IMF here and our information modeling, which you sort of understand what we are talking about a little bit. So we can start a discussion if what you see that we are making, if that fits into your the needs that you have. Yeah.
Yeah, it'd be interesting to hear any feedback right now about whether you guys, as technical authorities, see value in this, or if you have any additional questions about what I just presented.
Yeah, I don't think there are so many technical authorities here actually, but I'm representing Process. I think it's such generally speaking, I think it's sounds like a good initiative, but the actual work to implement it and practical consequences, I sort of can't fully see here and now. But just meaning that it's a complex picture.
Yeah, but I mean, you recognize yourself in what I presented earlier about how much time is used and resources for verifying, and I don't know what your like normal day-to-day is like.
Like Process, we don't purchase and own equipment, so we're probably less relevant, but we have like drawings and simulations. But anyway, just getting the connection between all the parts here in the hierarchy seems like a good idea, at least.
Yeah. Other inputs, questions?
Just to support Torbjørn, I think if all this was in place, the HACCPs could be automated, right? Because you could implement the rules, you could implement the questions, you could really run through all the P&IDs as we do today, because all the functions or everything would be a digital aspect of it. And it could really automate quite a lot of that manual process today. And you could, instead of finding the cases, you could discuss the findings. So it's one of the applications, at least I see in this, and because you could, the functional part of it would be accessible in that format.
Yeah, that's possible. I've seen something that looks a bit like that functionality marketed by another company here.
Yeah, but that's another.
We haven't actually used it, but
yeah, but that's another.
An
That's another reason, right? Like there are lots of companies who offer solutions, right? And then we could lock ourselves into a vendor and use their product
What I'm talking about is specific on HACCP and also on failure detection and understanding the consequence of failure.
Yeah. But I think the main point is just to make this, this common foundational language that we can all use, and build on top of that. Yeah.
And also a question that we've had many times when we had this presentation is, how do you deal with changing data and revisions, and how do you know that you're working on the latest data and the most updated version? And to that is that, well, as Veronica talked about, is the single source of truth. You work on the mother of the data always, and have always the latest data available. So you will always, what you will see is always the latest version. How that will be in practice, we're not sure yet, but that's at least the thinking.
Yeah, and that's also useful to be able to go back in time and kind of review the decisions that, you know, kind of pushed us to make the final, put together the final product, right, and commission it. So just version control in general is a big advantage. Yeah. So I showed the library. Everybody should have access to it, but it seems like there might be parts of the site that are down right now. But when it comes to suggesting IMF attributes, I do think that if I remember correctly, you have to be a member, your company has to be a member of PCA in order to do that. So I think everybody here is already, their company is already a member. So if you find value in IMF, which I hope you do, you could contribute to making the library better, to include the attributes that you find most important. And then we have, you know, kind of a data governance council that will review what you've submitted and decide whether it should be taken to the library. And especially if multiple people vote in the same attributes that they need, it's more likely that they'll come in. Yeah.
There's also a question from Arsalan in the chat. Do you plan to implement ISO 81346-5, that is suggestion of classification systems for relationship between the aspects?
I don't know what the status is on that. That's something that we'll have to take in our DISC meeting.
Currently, it's not in the discussion for now. But there is a forum established in PCA that can discuss these things, Arsalan, and I think you Enable is also a part of that forum.
Thumbs up, Arsalan says.
Thumbs up, yes.
All right. Any other questions, feedback? We don't have any Equinor leading advisors in this meeting, but that's something that we plan to take in another meeting. It was hard to coordinate with everybody, so many participants. So look forward to presenting there too, Idar. Great. So if there's nothing else, you can always send me or any of the DISC members an email with your inquiries. And I hope you guys take a look at the PCA library. Yeah, I think we can end this, give you guys 10 minutes back. All right, thanks for the meeting.
Excellent. Thank you all.
Thank you.
Bye.
Thank you. Bye-bye.